Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to discuss about DC coupled solar PV system. So this is the discussion from the continuation of AC coupled system in the last video. So please watch the AC coupled system so that it is easy to understand the DC coupled system. So it is another important discussion about how we are going to connect the battery. So where in the solar PV system, where we are going to connect the battery, how we are going to charge the battery, and how we are going to discharge the battery. So this is another system we call DC coupled system. So the name itself, the understanding here is that we are we are giving the importance for charging. So the equipment is the battery from the solar panels through the charge controller. We always need a charge controller to take care about the battery, how it's charged, the battery voltage and current, how much current is going to charge the battery and how much voltage is going to charge the battery. So the major equipment is solar panels, then inverter, battery, and then inverter. So here what is the idea here is mean whatever the solar panel produce, first we charge into the battery. So first thing is we are going to charge the battery. Then we do whatever we are going to do or whatever we need to do at a point of time. So here if you want to supply the power to the house, okay, during the solar power panel is producing the power, first you charge into the battery. Then from the battery we discharge the DC power and send it to the battery inverter. Then this inverter convert DC power into AC, then it comes to the house. Okay, so this is the way how these solar panels reach the house. And if you think that you are going to use a grid instead of battery, that's possible. The grid supply is coming to this inverter. This inverter, we usually use a hybrid inverter. It works as the controller, not only inverter, it as a switching process. It is taking care of the switching between the grid and between the battery. So it come to the house. So this is how we are doing to this the charging. Okay, now let's assume a scenario where we don't have a grid's power supply. Then we have to use the battery only from the solar panels is charged into the battery. Then we are going to supply the power to the house. So this is the path. So you may have a doubt. Okay, many people ask me why we are charging into the battery then discharging from the battery in order to supply to the house. So in this DC coupled system, the priority is always to charge the battery. Priority is charge the battery, and the house appliances in the last. If you compare this with the DC coupled system, where the last part is charging in in the AC coupled system, the last part is charging. But in DC coupled system, last appliances is the house call. So supplying to the house is my last priority while solar PV is generating. So what I mean to say, this DC coupled system is more suitable for the residential houses or off-grid system. If it is off-grid system, what we want, essentially we want to charge the battery in the daytime and we want to discharge the battery in the nighttime. It's simple. In the off-grid system, we don't have any resources in the nighttime. So if you have a solar panels and battery, in the daytime we want to charge the battery, in the nighttime we want to discharge the battery. It's very simple. So that job is done by a DC coupled system. But this is not suitable for the places where the daytime demand is too high. Let's say the factories or industries where the daytime demand is too high, then we don't want to charge the battery and discharge from the battery during the daytime. Okay, so this is more suitable where the daytime demand is low and the nighttime demand is high. So if you look at the residential houses, even in my house, daytime demand is low and nighttime demand is high. So I prefer the DC coupled system because I want to use the battery supply to power the house in the night time if I want to go off grid. Sometime I can use a grid supply to power the house. So DC coupled system directly charge the batteries from the uh, solar panels. So I highlight always very important things here. So whatever we need, whether we need to sell back to grid or export to the grid, or we want to supply to the house, we take all the energy from the battery. Very simple, right? We are going to charge the battery first. Then we are going to think we take the power from the battery to supply the house, or we take the power from the battery to export to the grid. It's up to us. We will decide whether we want to use the battery energy to power the house or export to the grid. In DC coupled system, DC power from the solar panels can be directly straight to the system's batteries. Okay, this system is more efficient than the AC coupled system in terms of charging, because in AC coupled system battery is in the last end, because we are giving the least priority for the battery in the AC coupled system. Here the first priority is to charge the battery. Okay, look at this diagram here. Solar panels we have, it generate power and send it to the hybrid inverter. This inverter charge the battery. Okay, this inverter, actually DC current is charge the battery. There's no conversion. This inverter work as a controller, because I said like hybrid inverter has an inbuilt controller. It's work as a controller as well as an inverter. And DC power, from the battery we take the power and convert into AC and supply to the house. If we decide to supply the house, sometime we supply the house directly from the grid, but it also come through the controller. This hybrid inverter work as a controller, so it comes through the hybrid inverter. So hybrid inverter here work as a switching device. Okay, it's work as a switching device as well as a converting from DC to AC. Okay, that's a purpose of inverter here. So what are the advantages? It's very high efficiency for charging, 99% of charging efficiency, because there's nothing in between solar panels and the battery, only the charge controller always work for the benefit of the battery, so to take care of the battery. So there's no other energy losses in between. So this system is great for off-grid system, because as I said, off-grid system, your main priority is charge the battery, because off-grid system mean there is no grid supply. So we always want to make sure that the batteries are fully charged. So then only we can be independent. We can run in the night time. So that's a main priority. So modular additional panels, we can add the additional panels later in this system very easily. There's an advantage. Disadvantage, it can become expensive because of a charge controller, because we need a charge controller. We need a charge controller. It take care of the batteries. And the low efficiency powering large AC loads. As I said, if you want to power the loads in the daytime, more AC loads in the daytime, let's say you are installing this system to hospitals or schools or factories, it is not recommended. We don't install DC coupled system. It is not advisable to install DC coupled system to a factory which is running heavily running equipments in the daytime, and nighttime it is shut down. Most of the factories in Asian countries are running in the daytime. So if that factory is running in the daytime, nighttime is shut down. What is the scenario? Load curve. Nighttime you only need a lights, just a lights, that's enough, very few loads. Daytime is heavily loaded. Now there's a question comes, why in the daytime I need to charge the battery and discharge the battery? Is a waste of energy. Instead of charging and discharging, I can directly convert the DC into AC through the inverter and supply to my load, so that I can save the energy. So that's why if your loads are high in the daytime, this is not recommended. Okay, and this is more complex to set up the system. We need multiple strings in required. You can watch the video about the string inverters, what is mean by string, in previous videos. This is one of the beautiful picture I take from the internet. It's saying about it's showing the DC couple system. We have the charge controller, we have a charge controller, and we have a battery, and we have the inverter, DC to AC inverter, and it goes to the lights. So this is a very important things here. So we come to the end of this uh, uh, video. The summary of this DC couple system is that you can always remember DC couple system mean you're going to charge the battery first. So priority is to charge the battery first. First thing in the current flow path, battery is the first thing. So you charge the battery first, then you decide either you're going to use the battery to supply the house, or the house is going to take the grid supply, or you're going to sell the battery store energy back to grid through the inverter. So those are the decisions. Those we can program the hybrid inverter, do the action. We can program the hybrid inverter, let's say half of the power export to grid, half of the power go to the load. We can share the power. Okay, we can do many things using the hybrid inverter. So the message here is that in the DC coupled system, we are taking care about the battery. We are charging the battery, because many people asked me why we are charging and discharging unnecessarily. Obviously unnecessarily. In the daytime, if you want to run the load using the solar panels in the daytime, obviously we are charging and discharging unnecessarily. But this system designed for off-grid system, where battery has to be charged fully. I mean, in a better way. I mean, at least it's 80-90%, so that nighttime battery will take care about the loads. Okay, it is mainly is for a off-grid system. It's more suitable for the off-grid system. But some people can installing for the grid connected system also, because sometimes grid goes blackout more frequently. Let's say your grid is not reliable, so you have a lot of blackouts, so the power cut. So in that case, you need to take care about your own power consumption by using the batteries. In that case, batteries are very important. Okay, that's all. Please subscribe this channel and provide your support, so that I can give similar to this discussion in a deep understanding. I always say that when we discuss more and more, uh, it is better for you to do a research or do a study or find a job, anything. It's easy for you to understand. You can't read all these things in the book directly. After learning from these small videos, you can go and read in the book, then your understanding will be much better. So thank you very much. I will see you in the next video.